Hello everyone. In this little lecture, we are going to talk about the addressing and pipelining in computer architecture. Firstly, we are going to talk about addressing. As you know, in assembly language, we can have load X or load 800, this kind of instructions saved in the memory. What is the meaning of load 800? Based on the instruction set architecture's definition, there can be several ways of interpreting it. So basically, there are several ways to design the instruction set architecture related with addressing. As mentioned here, these methods are illustrated in here, this includes immediate addressing, direct addressing, register addressing, indirect addressing, register, indirect addressing, index addressing, and base addressing. Well, so here we are going to look at this according to the examples. If we are going to load the number 800, then what is the value that is loaded according to different addressing modes? If we are using immediate addressing, then the data that is loaded is going to be the data itself. So immediate addressing means that the value loaded would be 800. Direct addressing means that if we say load 800, the data we want to load is actually the data sit at the address of 800. Then the data loaded will be 900. Indirect addressing means that we want to load a number, and that number address is here. So basically, indirect addressing needs us to go into 800, and it is the address of the variable we are looking for. Then we are going to look for at address 900, so we have 1000. The last one we are going to talk about index addressing. Index addressing uses register as an offset, which is added to the address in the operand to determine the effective address of data. So if we are using index addressing, then load 800 means we are going to use 800 as the number to be added to the number that is already in the register. So we are going to add 800 with 800. Then we calculate the address number would be 1600. In that case, we will be loading the value in here. So we use the sum of the value in register and the number after the load to calculate out the address. Then we catch the data here. So in that case, we are going to load 700. Yes, what we mentioned was right. That is about addressing. Then we are going to talk about pipelining. What is pipelining? Actually, most of the computer we use, the CPU that is working for us right now inside the computer, use pipelining. What is pipelining? So as we mentioned, for executing a bunch of instructions, if we look at the detail, for each instruction, it is actually having 3 cycles, including fetch, decode, and execute. Fetch, decode, execute. Normally, if we do not use pipelining, we would fetch, decode, execute the first instruction, then fetch, decode, execute second instruction, then fetch, decode, execute third instruction. However, in current CPU design, the designers realized that it is possible to overlap, to kind of process 2 together. They firstly make the fetch, decode, execute cycle to be broken, to be more detailed, more smaller steps like this. fetch instruction, decode opcode, calculate effective address of operands, fetch operands, execute instruction, and store result. These 6 steps, small steps, are written like this. Pipelining means that if we continuously have several instructions, then we can let them execute one, but before the ending of the execution, we can fetch the second instruction to let it start. So it is kind of related with parallel processing, but it is about, we call this pipelining. So in CPU, if there are different instructions, we want to do everything together, but we cannot do everything together because the CPU resource is limited. However, it is still possible to make the process overlapped like this. Okay, we can calculate out theoretically the formula of calculating how long it takes to complete a process is using this formula. Then the speed up, which is the previous time without doing pipelining, divided by the time that is using pipelining. Speed up S equal to this. But the interesting thing is that if we take the limit as n approaches infinitely, which means if there are many tasks, then the speed up S is equal to K. So here, we can say that if the n is super large, then the speed S is K. Okay, so pipelining is a very good technique to use, but it's not guaranteed that all the time that we can use it, because there are several constraints for using pipelining. I guess you can guess it out because it is possible when we were trying to do the pipelining, resources may conflict, data also have dependencies, and they are also conditional branching. Different reasons can cause pipelining to be impossible, but if it is possible, doing pipelining is a good thing to save the execution time. At the end of this PowerPoint, it talks about different real-world example of instruction set architectures. It talks about the Pentium chip, talk about MIPS chip. Each of these chip instruction set architecture may involve different addressing modes, different methods of pipelining, and also, for sure, each of them have a very different instruction set architecture because they are truly independently designed. At the very end, it talks about Java programming language. Java programming language is not built on a particular hardware machine. It is an interpreted language that is run on a software machine called Java Virtual Machines. Java Virtual Machine is itself is a software, but it itself has an instruction set architecture, which is called the bytecode. So that is why Java can run on a lot of platforms, because Java Virtual Machine supports it, and Java Virtual Machine normally can run most on a lot of architectures. And also, it talks about the ARM architecture. You can also read about it. ARM is also very popular architecture. So, we should have kind of think about to distinguish between different computer CPUs. For example, the PC we are using can use Intel AMD processors, and a lot of cell phones, Raspberry Pis, they use ARM processor. There's a picture here somewhere talking about the different percentage. Using the ARM processor, 95% of smartphones use ARM, 80% of digital cameras use ARM, and 40% of all digital television sets use ARM. So here, I believe we extended our discussion on regular CPU of PC to different CPUs, especially for different shape of computers. Okay, I believe in this lecture we understand better about addressing and timelining, and through reading, you may get more idea about what are different real CPU exist in the world and what are their particular features. I believe now when you read about some CPU use different addressing modes, different pipeline, we are able to understand more about what it's talking about. Okay, great. Thank you. That is for this little lecture. We have no more about instruction set architectures and no more about how CPU and memory work together.